Okay, let's start. Again, starting with organic first. And let me. Just a second. So this one now, starting with this one, which esters might be formed when lactic acid is heated? So esterification, it's about esterification. The first one, can this be formed when lactic acid is heated? So basically you just have lactic acid. Can you get this ester? I mean, this is how many carbon atoms? That's 1, 2, 3, right? So it's 1, 2, and 3. You got a double bond OH here, and you got an H and an OH here, and a CH3 over here. So can you form this ester? That if I have another molecule of lactic acid, this side is the carboxylic acid side, this is the alcohol side. So the OH is going to be lost and the H will be lost. And there's going to be an ester link that's going to be formed, because remember, lactic acid has both molecules, alcohol and carboxylic acid. So they're going to react and they would form this thing over here. TK, is this clear? So is this the same thing as this? Can you guys hear me?
Yeah.
Okay, so it looks, you got a CH3, you got a CH3 over here, you got a CH, you've got a CH. The CH has an OH branch, that's also there. Then you have CO2, so that's C with 2 oxygens, and then you have another CH, right? And that one has a CH3 branch, so that's also there. And finally, at the end, you have a carboxylic acid. So it's the first one is correct. What about the second one? Can the second one be formed?
Sure.
That will also form, because again, in this one, you'll have 2 lactic acid molecules. So this is one molecule, and there's going to be another one where the and that would be the other way around. It's OH, it would be just flipped around. It will have a CH with a CH3 branch and an OH on this side. So the carboxylic acid OH and H are lost. Alcohol carboxylic acid OH and alcohol H is lost, and they will connect in this middle part over here. So it's going to be the exact same thing. Serial bond O connected with oxygen, so it's exactly the same. What about the last one? Can the last one be formed? Without even drawing this, can the last one be formed?
No.
No.
Even if you take a cue from this one, the carboxylic acid reacts with the alcohol, right? So what is left is 1 OH and 1 carboxylic acid. So you can't have 2 OH groups left at the end, because the alcohol of one molecule will react with the carboxylic acid of the other. So that will leave you with 1 OH and 1 carboxylic acid. So you probably won't get 2 OH groups. Even if you try forming this one, these are the only 2 possible products that are possible. So that one having 2 OH groups, that's not possible. As moving to the previous one, we've got this reaction that's nucleophilic addition. So So which statement about the reaction of propanol with hydrogen cyanide are correct? Let me just double check. Have we done this paper before? TKS covers. One second. You haven't done M18, right? There was a similar question. Anyways, HCN is a weaker nucleophile than the nucleophile provided by NaCN. Is that correct?
Yes.
It is a weaker nucleophile. We did discuss this one that previously, that NaCN ionizes strongly and it produces Cn-1 ions, while HCN doesn't really ionize. So if it doesn't really ionize, the negative charge is smaller. So a nucleophile is attracted to positive things. So Cn-1 would be strongly attracted to positive things. It's going to be a stronger nucleophile, which is why it's used as a catalyst. The reaction mechanism involves two steps. That is also correct. And the product of the reaction has a chiral carbon atom. If you draw this one is chiral. This is what nucleophilic addition is. It's got two steps. Cn-1 attacks and Cn-1 joins, and then the next step, the H comes in. So this is nucleophilic addition. Moving to the next one, we've got organic compound X gives a precipitate when warmed with aqueous silver nitrate. The precipitate dissolves with concentrated aqueous ammonia. So whose precipitate, halogen precipitate, halide precipitate, dissolves with concentrated ammonia?
Bromine and chlorine.
Okay, so it's going to be both Br-1 and also Cl-1. I mean, Cl-1 dissolves anyways. Like, it doesn't even need to be concentrated. It can't be I-1, so that's gone. Basically, those are the two options. And that was it. I mean, this one will provide the bromide ion, this will provide the chloride ion, and you'll have a precipitate that will dissolve. You got a PVC, that's an addition polymer, which statements are correct. On combustion, PVC can produce carbon monoxide, carbon dioxide, and HCl. Is that true? What is PVC? PVC is?
Yes, it's true.
See, that is true because PVC has one chlorine. So it can possibly provide all three of them. When it's buried in landfill site, it will not significantly biodegrade.
Sir, but how it will form carbon monoxide? I mean, there should be limited oxygen for that.
They didn't tell you whether it's limited or not. They're just saying that it's randomly getting burned. As a polythene is buried in a landfill site, will it significantly biodegrade? It will not. That's true, right? And remember, remember this, although condensation polymers are not in your course at the moment, but addition polymers, all of them, they don't decompose that much. The carbon chain is very, very stable. The empirical formula of an addition polymer is the same as that of the monomer. That's also true. I mean, the whole polymer is just a repetition of the monomer, right? So they both have the same empirical formula. In which different forms does nitrogen exist in compounds? Bonded by a triple covalent part of a cation has an oxidation state of +5. Which three are correct? Or which?
All of them.
So which cation does nitrogen belong to? Like
NH4.
Okay, that's NH4 +1. When does nitrogen have a +5 oxidation state? Like, does it have a +5 oxidation state? You don't. What's the oxidation state of nitrogen in NO3 -1?
+5.
Okay, that is +5, so that's also true. And obviously, it can form a triple bond in N2. Chlorine reacts with hot aqueous NOH. Which oxidation state does chlorine show in the product? So what will happen when it reacts? What two products would be formed? Hot NOH.
NaCl and NaClO3.
Okay, so it's going to produce NaCl and NaClO3. So what are the oxidation states? Is -1 correct? I mean, it is -1.
Yes.
What's the other one? What is this oxidation
Plus
state?
5.
Plus 5.
Plus 5.
Okay, so that's not there. So only one is correct. In which reaction does NH3 behave as a Bronsted-Lowry acid? What does an acid do? It produces
H plus ions.
okay, proton donor, right? So which options are correct? NH3 acting as an acid.
1 and 2.
In the first one, it is acting as an acid, right? It's producing an H plus 1. Because when the H plus 1 is lost, it turns into NH2 minus 1. What is NH3 behaving as in number 2?
A base.
It's behaving as a base. So that's so that's not true. So it's behaving as a base. The third one is it's not doing anything. It's neither accepting it.
Like, why is it acting as a base?
Because NH3 accepted an H plus 1. I mean, it had 3 hydrogens and then there was an H plus 1 that got added over here. So when something accepts H plus 1, over here it's not doing anything. In this last one, it's not doing anything. So number 2 is wrong. Number 3 is also wrong because it didn't do anything in the third one. Remember, complex ions are formed when something dissolves. Over here, it's just dissolving. I mean, don't get confused by this. When something dissolves, like silver ions dissolves in ammonia, the ammonia, liquid ammonia, it gets attracted because it has lone pairs. It gets attracted to the silver ions from all sides. So that's what a complex ion is. So nothing happened to ammonia as such. Which statements are correct? Ammonia behaves as a reducing agent. Is it behaving as a reducing agent here? How did the oxidation state change?
Getting oxidized, so it's behaving +3 to +4, so oxidized.
-3
To 0.
to 0. And over here, it's also -3. I mean, this is NH4 plus 1, right? So H is +1, that's +1 into 4. And you don't know the total charge on the entire thing is +1. So if you solve for X, it comes out to be -3. Over here, it's also -3. So in one of the products, it is getting, what's happening to it? Oxidized or reduced?
Oxidized.
Oxidized.
So it is a reducing agent, right? So it's going to be a reducing agent. Ammonia behaves as a base. Is it behaving as a base in this reaction?
Yes.
Yes.
It accepted an H plus 1, right? So it's behaving as a base and the oxidation number of hydrogen changes. So which it doesn't, because hydrogen is +1 over here and it's still +1 over here. So it does not change. A container is partially filled with hot water, sealed and left to cool, which statements are correct. As the temperature increases, water molecules lose energy. Left to cool, decreases, sorry.
Yes.
Just a second. Just hold on 1 second. Sorry, can you hear me? Hello?
Yes. Sir, are all three of them correct?
All three of them. As temperature increases, water molecules lose energy. That's obviously, remember, kinetic energy is the same thing. I mean, temperature measures kinetic energy. Remember that. Okay, so temperature is a measurement of kinetic energy. Temperature decreases, more water molecules move from vapor to liquid. From vapor that is correct, right?
Sir, why is the first one wrong?
The first one?
Yes.
Because if temperature is decreasing, that means they are losing kinetic energy. Water is becoming colder. And remember, temperature is a measure of kinetic energy. If something has a lot of kinetic energy, that means its temperature is going to be high.
So the first one is correct. Yes.
Yeah. Yes. As the temperature decreases, more water molecules move from vapor to liquid. That is also correct. It's going to start condensing. And as the temperature decreases, the vapor pressure of the water also decreases. All this part is not in your course at the moment, but I'll just quickly explain. Actually, we're not pretty sure whether they've removed it or not. It's not part of the syllabus anymore. I mean, it's not written in the syllabus anymore. But I'll just quickly explain. What is vapor pressure? It's when you have a liquid, there's a vapor that's on top of it in a closed container. And that vapor exerts a pressure. Like if you have a Coke bottle or a Pepsi bottle, there's vapor that's created and that vapor exerts a pressure. So that is vapor pressure. So if the temperature decreases, there's going to be less vapor, because at a lower temperature, the amount of vapor is going to be lesser. And if it's lesser, the pressure that is going to be exerted is also going to be lesser. So that is also true, because you're going to have less vapor, less gas, and less pressure exerted by that gas. Moving to the next one, Q contains 40% carbon by mass. I mean, you would have to solve each one of them one by one individually, and you can pretty much do this on your own. The first one is, if you know what glucose is, that's 180. So that's 12 into 6, that's 72. Carbon is 72 divided by 180. Is that?
It's
So
44%, sir.
Yes, 40%.
No, that's 40%. That is 40%.
Yeah, my bad.
The other two are probably going to be incorrect. Why? Because you need this ratio. I mean, I'm assuming you can measure this on your own. Try this on your own. This one, how many structural isomers with the molecular formula C4H10O give infrared? So you're looking for isomers and structural isomers, right? And they should have infrared absorptions both at approximately 1200 as well as 3400. So what is the absorption at 3400?
Alcohol OH?
It's an alcohol OH. Like if you have a data booklet, around 3400 is definitely this one, 3400. Above 3200, it's alcohol OH. And what's 1200? That's going to be this one. The C single. Whenever you have an OH, you also have a C single bond O as well. This one as well. So we're basically looking for alcohols. And so how many isomers do we have? 4 carbon atoms, right? So the first thing is I'm going to draw positional isomers. So the OH could be over here. The OH and no stereoisomers. Only structural. So these are the only 2 possible positions. Then I can have a branch. So the OH could be over here. The OH could be on any one of the carbon atoms. It's the same thing, right? The other option is that the OH would be on the middle carbon atom. That's it. So I'll have 4. I'm getting 4 at least. So there would be 4 possible isomers. I can't make any more branches with this one. So only 4 possible isomers are possible. Okay. So moving to the previous one. Alcohol, aldehydes, and nitriles can each be converted into carboxylic acid. Which description of the conversions into carboxylic acids are correct? How do alcohols get oxidized to carboxylic? I mean, they get oxidized. I did use the word. How do aldehydes turn into carboxylic acids?
Oxidation.
Yeah, that's also oxidation. How do nitriles turn into carboxylic acids?
Hydrolysis.
Okay, that one is hydrolysis. That's the one with dilute acid or dilute alkali. So it's C. Ethane dioic acid has this formula. What is the formula of aluminium ethane dioate? So remember how salts are produced. Salts are produced like, remember acid-base reactions of carboxylic acids. Whenever you have a reaction, whether it's Na or NaOH or Na2CO3 carbonates, the salt is always produced that the carboxylic acid ends up losing its H and it gets replaced by the metal ion. And with the metal, it's going to be hydrogen gas. If it's a base, NaOH, it will produce water. If it's a carbonate, Na2CO3, it will produce water and carbon dioxide. But that's how the salt is produced. The H is lost, replaced by whatever cation is coming in. Now you've got aluminium ethane dioate. So aluminium is going to have, so how many H's would be lost in this case? It's a double carboxylic. So it's a double carboxylic acid, so it's going to produce 2 H plus 1 ions, right? So the whole entire thing has a charge of -2. So if aluminium comes in, aluminium has a charge of +3. So if it's got a charge of +3, what is the formula now?
D.
It's going to be Al2 and this would be 3, right? If you do crisscross. So that would give you D, right? Okay, is that clear? -2 charge on the entire thing and +3 charge on this thing. So the answer would be D. Now this one, you've got 1 chloropropane. It's heated in a reflux with sodium hydroxide dissolved in ethanolic. What happens when you have ethanolic NaOH?
Alkene forms.
Okay, so ethanolic halogenoalkane, NaOH ethanolic, that would turn into an alkene. So an alkene will be formed 1 chloropropane. So propane and 1 Cl. So the Cl will be lost and there's only one position where the double bond would be, and that's this one. So the type of reaction is elimination and it's going to form propene. So it's going to be B. 26X compound X produces a carboxylic acid when heated in reflux with dichromate 6. Compound X does not react with sodium metal. So X produces a carboxylic acid when it's oxidized. So what could be X?
Aldehyde.
Aldehyde.
It could also be a primary alcohol, but since they've stated that it does not react with sodium metal, it can't be an alcohol. So it's going to be A. Is that clear that alcohols, they end up reacting with sodium metal and they would produce the same type of salt. So it can't really be an alcohol. But aldehydes do get oxidized to carboxylic acid. So yeah, clear?
Yes.
Now this one, which volume of hydrogen measured in a room condition is produced when 0.16 grams of, now this is methanol reacting with, methanol has 1 OH, 1 carbon. It reacts with sodium. So the salt is going to be produced in the same way the H would be lost. It's going to become CH3, O-1 and Na+1. Plus H2 gas is going to be produced. And if I want to balance it, there's going to be half H2 gas. So he's saying 0.16 grams of methanol. So how many moles is this? 0.16 divided by the MR of this thing. What is the MR? That's 12 plus 4, that's 16 plus 16. That's, is it 32? Can you just confirm?
Yes.
So how many moles is this? This is
5 into 10 raised to power -3.
Okay, so the amount of H2 would be 2.5 times 10 power -3 moles, right? Half of that, right?
Yes.
So what is the volume multiplied by? So multiply this by what? At room temperature, right? So multiply this by 24. Make sure you read this, whether it's room temperature or not. So multiply by 24. What would that give you?
34,000 actually.
0.06.
60 cm cube, right? I mean, that would be in dm cube.
Yeah.
So we've got this question now. Now structural and stereo both should be considered when answering this. The molecular formula of compound X is C5H12O. The compound X reacts with alkaline aqueous iodine. So that's the iodoform test, which is that it either has CH3C double bond O and the rest of the molecule, or it has CH3CHOH. So the iodoform test is going to be positive. So it can't have a ketone because ketones, remember ketones, the general formula for ketone is like if it has one ketone, that's CnH2n, CnH2n and O. Ketones have hydrogens which are double the amount of carbon atoms normally if you have a simple ketone. So it can't be a ketone because it looks like an alcohol instead. So I'm going to go with this one. It's an alcohol. Otherwise, your hydrogen atoms would not be 12. And it can be dehydrated to form two alkenes. So the two conditions given. So it has to dehydrate as well. So 5 carbon atoms, I'm going to draw all of them. So I've got the first one, which is CHOH. I'm left with 3 carbon atoms. That's 1, 2, 3, right? That's 1. Then I'll have another one, which is I'll have CH3CHOH. The 3 carbon atoms could be arranged in this way, right? Is there any other way apart from these two? Is there any other? First, tell me which. Is there any other possible way that I can make an isomer?
No.
There's no other way because I need this structure and I need carbons. The 3 carbon atoms can only be arranged in these 2 ways. So it has to dehydrate to form 2 alkenes. How many alkenes will this form? Remember, it can be dehydrated to form 2 alkenes. So the OH is going to be lost, right? And you'll get a double bond at either this point or this point, right? The second one, the OH would be lost and you'll get a double bond either at this point or at this point, right? So both of them, the ones that I've drawn, they can be dehydrated to form 2 alkenes, right? Or not. Which one out of the 2 is correct? Who's
Is it
making
the top one?
Who's making more than 2 alkenes? Remember, this one is making more than 2 alkenes because there's going to be cis and trans as well. Like if you put a double bond at this point, the molecule will have cis and trans isomers. So you can either have a double bond at this point. If it's at this point, it won't have cis and trans, but because this carbon will have 8 atoms only. But if you put a double bond over here, the 2 sides over here will be different as well, and the 2 sides on the other carbon atom would also be different, which is why it's going to have cis and trans versions. So this one would actually make 3 isomers. This double bond will have 2 versions, cis and trans. Is that part clear?
Sir, won't the other one as well make cis and trans?
No, it won't, because if you put a double bond over here at this point, it won't make cis trans because this carbon is bonded to the same group on both sides. Is that clear?
Oh, okay. Yes.
And if you put a double bond on the other side, the carbon is bonded to 2 H's, so that will also not make cis trans. So you'll have just 2 alkenes, one over here, one over here. That's no further versions of it. So the molecule that we are looking for is this one. It's this is the correct one. That it can be dehydrated to form 2 alkenes. This is the one that's dehydrating to form 2 alkenes. Is this clear to everyone?
Yes, sir.
So coming back to the alcohol, which one is the right structural formula for this one? This one. You got a CH3, CHOH, right? So I've got a CH.
C and D both have it.
I've got.
The first two are already wrong since they don't have the hydrogen.
I think it's C. Like if it's the same one, just written backwards. Now you've got a CH3, so I've got a CH3 on this side as well, right? I've got CH with an OH, so I got a CH. The next CH is with an OH. And after that, I've got another CH. This one will have CH with two CH3 branches, right? So I got a CH with two CH3 branches. So this is exactly the same as this one, just written backwards.
Sir,
Yes.
why did you cancel out the one on top?
Because it was making three isomers, three alkenes. If you dehydrate it, double bond would either be over here or it will either be over here. When it's over here, it's going to have two versions. It's going to have cis.
Yeah, okay.
So which is why that would make it three alkenes, right?
Yeah.
Because he had already told you that you had to consider stereoisomerism as well. Is the question clear? Yes or no? Is this clear?
Yes.
Yes.
As the next one, which compound reacts with 2,4-DNPH reagent but does not react with toluenes? 2,4-DNPH. Who reacts with 2,4-DNPH?
Aldehyde, ketone. Carbon.
Okay, so and who does not react? So it's basically a ketone he's talking about. Yeah. So he's talking about a ketone. So which one is a ketone out of all of these? And only.
But A will react because C has aldehyde.
Okay, so both A and C have ketones, but C also has an aldehyde, so it will also react with toluene. So C can't be the right one. We've got this one. What could be now? This one is I mean, these ones are interesting questions. You got an alkene. All of them are alkenes. He's saying which one will get converted into this thing. First question: how will you convert this into this thing? Or any one of them.
Strong oxidation.
Take a strong oxidation. Strong oxidation is going to break the double bond. So all their double bonds are going to, let me remove the double bonds. A second. So all their double bonds would be gone. So double bond gone here as well. Now, the next part is what happens to these carbon atoms. What happens to this carbon atom, two carbon chains? What will it turn into?
Ketone.
Ketone.
That will turn into ketone, and this one, the other one, it only has one carbon chain on one side.
Carboxylic.
Okay, that's carboxylic acid. Okay, just a quick recap. No carbon chain around it, carbon dioxide and H2O. One carbon chain, that's carboxylic acid. Two carbon chains, that's ketone. So is this the right one? Is this or not?
Yes.
First carbon atom, that matches. Second one, double bond O, that also matches. Third one, that also matches. Fourth one also matches. On the fifth one, you got a branch, so you got a branch over here on the fifth one. Sixth one, you got a carboxylic. So everything matches, right? So this one is the correct one. Is that clear?
Yes,
so
sir.
everything works out. Anyways, let's move to the next one. Inorganic. Haji.
सर उन्होंने कहा compound X can be converted into compound Y, लेकिन उसके अंदर कोई further reaction तो नहीं बता?
You had to figure this out on your own. That you had an alkene, and that alkene was turning into this. So,
okay.
I mean, that was strong oxidation, right? As the next one is, okay, we've got which type of isomerism are shown by 2,4-dimethyl hextuene. Hex, first thing, 1, 2, 3, 4, 5. Yeah, we left a question. And this one. An organic ion containing a carbon atom with a negative charge is called a carbon. I think that's a carbon anion, right? carbon atom with a negative charge. An organic ion containing a carbon atom with a positive charge is a carbocation. And the reaction between aqueous sodium hydroxide and 1-bromobutane proceeds by an Sn2 mechanism. What is the first step in the mechanism? So first thing, Sn2 mechanism, I'll just, is it a one-step reaction or a two-step reaction?
One step.
Okay,
One step.
that's a one-step reaction. That's this one. He's talking about a primary halogenoalkane. The carbon halogen bond, which is polar, the positive will be attacked by the nucleophile directly. And the Cl will be pushed away from the other side. The OH ion will come in, the Cl will get knocked out. So what's happening? Attack by a nucleophile on a carbon atom with a partial positive charge. Is that true?
Yes.
That is true. Right, it's this one. Nucleophile attacking a carbon with a partial positive charge. That's it. An electrophile is obviously not attacking. You wouldn't have a carbocation because carbocations happen in Sn1 mechanisms. In Sn1 mechanisms, the carbocation is formed, then the OH ion comes in. So that is Sn1, not Sn2. As another previous one, we've got which type of, so hex 2-ene, so that's 6 carbon atoms. 2-ene means double bond over here, and 2,4 dimethyl. So 2, there's a methyl. 4, there's a methyl. So tell me what isomerism will happen in this one.
Optical.
You won't have cis trans, right?
Yes.
So you won't have cis trans because you got double bond has the same 2 carbon atoms. So it's going to be optical isomerism only, and this is going to be the optical isomerism. It's got 1H. All 4 sides on this carbon atom are different. So the previous one is 1 molecule of ammonia reacts with 1 molecule of ethyl methanamide to produce 1 molecule of methanamide, and only 1 molecule X. 1 molecule of methanamide decomposes on heating strongly to produce 1 molecule of ammonia and only 1 molecule of Y. So what could be the identities of X and Y? So so this is methanamide, that's HCO. So that's cetyl bond O and NH2. Now 1 molecule of methanamide decomposes on heating strongly to produce 1 molecule of ammonia. So 1 molecule of ammonia, so it decomposes, it produces 1 molecule of ammonia. What is the other thing then? What is X? On 1 molecule of methanamide decomposes.
Because we use ammonia and ethanol for.
One second. What could be the identities of X and first thing? What is it? This is not X. This is Y actually. According to the question, this is Y. And tell me what Y is. Y is going to be carbon monoxide because remember he has clearly stated that 1 molecule produces 1 molecule of this. So what is left? You just
carbon and oxygen.
You just have CO left. That's it. So Y is definitely carbon monoxide, right? The X is something else. It's he's saying that so 1 molecule of this thing, right? 1 molecule of this thing produces 1 molecule of methanamide. So and it reacts with 1 molecule of NH3, right? And produces 1 molecule of methanamide, that's HCONH2. So again, what is left? And 1 other molecule. So one of this reacts, produces exactly 1 of this, and 1 molecule of X. So what is X? What's left? I've got 2 carbons left, right? And I've got how many hydrogens left? The total hydrogens I had initially was 6 plus 3 over here, that's 9.
6 hydrogens left.
So I'll have 6 hydrogens, and I think I've got one
One
oxygen left.
O.
One oxygen left.
Ethanol.
So that is ethanol, because for ethanoic acid you need 2 oxygens, so it's going to be ethanol. Okay, so C is correct. Clear here? Is this clear? So is the previous clear? It was more about balancing equations. Amides are not in your course. I mean, the whole reaction wasn't in your course. It was more about balancing equations. Now, when burnt sulfur forms a gaseous product X, what is produced, and which is oxidized to produce a gas Y? What is X?
Sulphur dioxide.
That's sulfur dioxide. This is sulfur trioxide. And Y reacts to produce a product. Y reacts with water to produce a product Z.
H2SO4.
So
Sulfuric
SO3,
acid.
because that's H2SO4. And which row correctly states the oxidation state? What's sulfur over here?
Plus 4.
Plus 4.
Because it's going to be D over here. It's plus 6, and over here it's still plus 6. H2SO4. You can find the oxidation state that is still plus 6. So then you have this reaction. Which row is correct? Strongest oxidizing agent.
B.
First thing, in the final stage, 2 redox reactions take place. So the strongest oxidizing agent is, it's definitely Cl2, right? The smaller atoms, oxidizing agents, remember, they like to gain electrons. Who is the weakest reducing agent, oxidizing agent?
Sulphur dioxide.
So I guess C.
So you have to do this based on this one, right? What is happening to Br2? Br2 is going from 0 to -1, right? So it's getting reduced. So what is it behaving as? It's behaving as an oxidizing agent, right? Is that clear? So Br2 is behaving as an oxidizing agent. What does Cl2 do? Cl2 is an even more powerful oxidizing agent than Br2. How did we know that it displaces Br? When both of them are present, then it's Cl2 that ends up gaining electrons, right? So that means it's an even powerful oxidizing agent compared to Br2, right? The weakest one is sulfur, because what happens to sulfur? Sulfur is plus 4, and over here sulfur is plus 6. So it instead got oxidized. And who gets oxidized? The one that is behaving as a reducing agent. So sulfur isn't even behaving as an oxidizing agent. So that's the weakest one. Is that clear based on the data that's given to us? Is this clear, this question?
Yes, sir.
Yes.
The next one, because remember, although you do know from group 17 that Cl2 is the strongest oxidizing agent, but you should, maybe they give you some other elements, but they give you equations for that. So you should be able to interpret the equations. Now, the volatility of group 17 elements decreases down the group. What is responsible for this? Why does the melting point increase?
Is it D?
So the number of electrons increase, you get more van der Waals forces, bigger molecules. You get bigger molecules, you have more van der Waals forces. I've got this one, Mg and Sr2 plus at the same concentration. The solution is divided into 2 equal portions. NaOH is added dropwise to one portion. Dilute sulfuric acid is added dropwise to the other portion. Who's going to form a precipitate with NaOH? This one or this one? Whose hydroxide is insoluble?
Magnesium.
Mg.
Okay, so magnesium hydroxide, the top one, hydroxides are insoluble. So the precipitate seen with NaOH is added. That's going to be magnesium hydroxide. Who's going to form a precipitate with the sulfate when sulfuric acid is added? Who's strontium? Because down the group, remember it's opposite. Hydroxides, the solubility increases down the group. Sulfates, their solubility decreases down the group. So it's going to be strontium sulfate. That's going to form the precipitate with sulfuric acid. To get down the group, the sulfates are insoluble. हाँ जी.
सर तो solubility जितनी कम होगी मतलब precipitate बनने के chances ज्यादा है ना?
So you're saying that if they're insoluble, so they will make a precipitate. They will make a precipitate.
They will make a precipitate, yes. Because if Mg and you add NOH, right? So basically you're introducing OH ions to the solution. They would combine together. And MgOH2 is not soluble, right? So it would immediately form a precipitate. A solid precipitate would be formed at the bottom. Is that clear?
So, so general question है. So carbonates का क्या होगा down the group?
They're all insoluble.
Okay. Sir.
And chlorides are all soluble. Actually, well, X, Y, and Z. See, X reacts with chlorine to give a liquid product. So who's X? Well, it can't be NaCl, right? Is NaCl liquid? It's not. It's an ionic solid. MgCl2 is the same thing. Who's a liquid product? In period 3.
Phosphorus.
Okay, that's possibly a liquid PCl3.
SiCl3? Or, I mean,
It's a SiCl4. These two. These two are liquids. So you've got two options for X, and Y reacts with chlorine to give a solid product that dissolves in water to give a solution of pH 7. So who's chloride?
Sodium.
NaCl.
Okay, that's NaCl. And tentatively could be MgCl2 as well, but MgCl2 is not exactly 7. But we'll go with NaCl for now. Z reacts with chlorine to give a solid product that dissolves in water to give a solution of pH 6. Now this one, who's slightly acidic?
Magnesium.
Okay, that's magnesium. That fits magnesium. So you've got, so which elements are good conductors of electricity?
Y and Z.
So it's going to be Y and Z. Mg and Na, not phosphorus. The first ones are covalent. I mean, the elements are covalent as well. Basically non-metals. Which oxide is insoluble in aqueous NaOH?
Magnesium.
So this is a base, and this is also a base. So no reaction. This is amphoteric, this is acidic, this is acidic. Which statement about the effect of a catalyst on a reversible reaction is correct? The activation energy of the forward reaction stays the same. The composition of the equilibrium mixture stays the same. The rate of the backward reaction stays the same. The value of the equilibrium constant changes. So what does the catalyst do?
So no effect.
It increases activation energy.
So the first one is wrong, right? It doesn't stay the same. It lowers the activity. So which statement is correct out of these? It speeds up the reaction no matter whether it's the forward or the backward. Remember, equilibrium constant value only changes with one thing. And what is that one thing?
temperature.
So it's not catalyst. So the answer is the composition of the equilibrium mixture stays the same, because both forward and backward reaction would speed up at the same time or at the same speed. So there will be no effect on the amount of reactants or products. Is that clear? Now, the next one is the reaction between sulfur dioxide. Remember this thing that equilibrium composition only changes with three things. One is concentration, one is pressure, the other one is temperature. Pressure is for gases only. So otherwise, the equilibrium mixture remains unaffected. Both forward and backward reactions would speed up if you add a catalyst. So this one, which conditions of pressure and temperature favor the reverse reaction? What's the answer? Reverse reaction. You want to send it back. Concept B?
C.
C, low pressure. Low T, that's fine. Low pressure, it will favor the more gas mode side, which is this one. High temperature will favor endothermic. The forward is exothermic. The backward is endo. Right? So the endo is going to be favored and less gas. Sorry, more gas. Low pressure, you'll have more gas. Okay, anyways, the next one is we've got which reaction is not a redox reaction quickly. Which one is not a redox?
Is it D?
It is D because it's +6. You can H2SO4 is also +6, so nothing happens there. In the first one, Mg is obviously changing from 0 to +2. Over here, you got oxygen going to 0. Oxygen was -2, now it's 0 as an element. Sulfur is clearly getting oxidized over here. So they're all redox except for the last one. We've got an enthalpy change question. What is the enthalpy change of this reaction? And the data can be bond energy data. So how many bonds are you breaking? So you're breaking, I guess, 4 CH bonds, right? You're breaking a C double bond C bond as well. You're breaking an HBr bond. Be careful with the number of bonds that are broken. They're all going to be endothermic. So bonds broken, and make sure you count them correctly. And how many bonds are formed? They would all be exothermic. So you're forming 5 CH bonds. You're forming 1 C single bond C, and you're forming 1 CBr bond as well. So I would have to open the data booklet for this, and CH is 410, I guess. CH, that's 410. So I've got 410 into 4. And C double bond C is what? C double bond C is, where's C double bond C? This one, 610. And I've got an HBr, where's HBr? That's 366. And -5 CH bonds, right? So that's 5 into 410. And they're all going to be negative. Or I can get rid of the bracket, just put negative signs next to it. Bond formation is exothermic. C single bond C, that's what we are forming as well in the product. So that's 350. And I've got a CBr bond as well. So where is, that's 280. So what do we get for this?
-64.
Just make sure, be very careful with these questions. It's very hard to actually miss the number of bonds. I mean, you should at least draw the structures properly, count the bonds properly, and be careful with the negative signs and the positive signs. Bonds broken, they will all be endothermic. Bonds formed, they would all be exothermic. So bonds broken minus bonds formed. Which equation represents the enthalpy change of formation of water?
B.
B? B is fine.
Mm.
1 mole of water, and it should be in its standard state. So because they use the word standard, so it's got to be liquid from its elements, and the elements have to be standard state as well. So half oxygen. I've got this one. Assuming what is the pressure in the vessel? So we need to PV0 nRT. So it's going to be N. How many moles do we have? That's
Sir, can you explain why the rest of them are wrong?
the rest one. Water should not be a gas, right? So these two are wrong because standard conditions, right? Room temperature, 25 degrees centigrade. So it's going to be a gas. And over here, the reason this is wrong is you're getting 2 moles. Enthalpy of formation is 1 mole of water formed. So this is also, you got 2 moles of water forming. Is that clear?
Yes.
So next is we've got PV0 nRT. So you have to find, you already gave you the equation. So the oxygen moles N 0.960 grams divided by the oxygen gas is, remember, O2, so that's 32. NR is 8.31. Temperature has to be in Kelvin, so this is going to be what? 273 plus 303, right? And divide the whole thing by V. Volume must be in meter cube, which they have already given. So make sure the units are written carefully. Otherwise, the question is simple. So what's the answer? What's the pressure?
We divide the mass with the
A.
10.8.
Nee, what's the question? We divide the mass by?
32.
Volume.
N is moles, right? So N is moles. So you find the moles of oxygen, right? That's 0.960 divided by 32, which is the MR of oxygen. Anyway, so remember your pressure will come out in pascals. It's going to be in pascals. So the answers are given in kilopascals. So what is the answer? A?
10.8.
Sir, C.
See? Okay. Just be careful. The equation will give you the answer in pascals and the answers are written in kilopascals. So divide by 1000 at the end. So we've got this reaction, 11,000 dm cube sample of an aqueous solution. The concentration of acid is this, and what mass of solid sodium hydroxide neutralizes this acid? So first thing, can you find the moles of the acid? What is moles? Concentration times volume, right? So you're given the volume of the H+1, and you're given the concentration of H+1 as well. So how many moles is this?
13.86.
So if you do concentration, 13.86 moles, right?
Yes.
So one H+1 requires one NaOH, right? I mean, the OH ions are coming from NaOH, right? So one H+1 requires one NaOH. So you need how many NaOH? You need 13.86 moles of NaOH. Is that clear as well? So, so the next part is what is this mass of it? So multiplied by the MR of NaOH, which is 23 plus 16 plus, that's 40, right?
D.
So it's going to be D, right?
Yes.
Okay, so
This one, I think.
no, you had the concentration of H+1 and they gave you the solution volume as well. So if you have concentration and volume, you can find the moles, right? Is that clear? The volume and concentration were given. Is that clear?
Actually, kind of less than that, I think.
Okay, so you got 13.86 moles of this. So the amount of NaOH would be exactly the same. It's 1:1, right? So the amount of NaOH would be 13.86 moles exactly. So and multiplied by the MR to find the mass. That's it. So number 5 is 4.1 grams of calcium nitrate decomposes. So what's the equation of calcium nitrate decomposing? This is the equation and 4.1 grams. And he's saying what mass of solid residue? He's talking about this one. This is the solid residue. So how many moles is this? 4.1 divided by the MR, which is 40.1, 14 into 2, that's 28, 16 into 3, 16 into 6, that's 124. This is going to be 160.1. That's going to be 164.1. 1 second. Can you just confirm what's the MR? Find the moles of calcium nitrate.
0.025.
So we're getting 0.025 moles. And the moles of calcium oxide would be exactly
0.02.
How much did you get? 0.025 moles for this? Can you hear me?
Yes, 0.025.
And you multiply it by the MR, that's 40.1, that's 16, that's 56, right? So what do we get? Okay, so we're getting C. Achha, which molecule contains a nitrogen atom which is sp hybridized? Which one is sp hybridized?
HCl.
Okay, that's it. And remember the rule that carbon. This rule applies to all three. If no pi bond, right? That is sp3. Single bonds only. If one pi bond, then that's sp2. If you have two pi bonds, that is going to be sp. So in HCN, both carbon and nitrogens are sp hybridized. They're forming two pi bonds. So both of them are forming two pi bonds. So this is going to be sp hybridized in HCN. In NH3, so this is sp. I'm going to do all of them. In NH3, that's going to be what type of hybridization is NH3? If you have single bonds, that's sp3, no pi bonds.
Okay.
So you can remember, and this is sp3 as well. And last few, you've got.
Can you repeat those? Sorry, it's just that my internet is lagging.
The rule is simply that if carbon is not making, remember you've studied hybridization, if carbon is not making any pi bonds, like in CH4, only single bonds, then this is known as sp3 hybridization, no pi bonds. The same applies to NH3 as well. If it's not forming any pi bonds, it's going to have exactly the same shape, except that one of its orbitals is going to be complete. It's going to be already full. There's going to be a lone pair, but the two atoms would look exactly the same, except that this orbital nitrogen has a lone pair. It's already full. It doesn't make an extra bond over here. It forms a dative bond sometimes, but otherwise it's going to be sp3 hybridized. And the same applies to oxygen as well. That oxygen also has the same shape. It's because it's got two lone pairs. So two of its orbitals are already full, and two of the orbitals are bonding. So they're all identical. So the rule is simple. You just keep it simple. You don't get a big question on this. The rule is simple. If these three, someone out of these three, if they're not making any pi bonds, that's sp3. That's tetrahedral. Although this would be trigonal pyramidal and this would be bent, but they would all have, the basic shape is kind of the same. If it's making one pi bond, that's sp2 hybridized. And if it's making two pi bonds, that's sp hybridized. So how many electrons are present in a hydrogen carbonate ion, which is HCO3-1?
Is it
So how do you,
32.
the first thing, hydrogen has 1 electron, carbon has 6, right? So that's 1 plus 6, and oxygen has normally how many electrons? 8, right? 8 into 3. So you got 24 plus 6, that's 30 plus 31, right? And it's got a -1 charge. That means there's 1 extra electron. So it's going to be 32. The electronic configuration of the two outermost shells of an atom is this. What is this atom? So it's 4s2 3d5. You just have to figure this out. This one is probably manganese. Manganese. The first one, manganese. That's you can go and have a look. It's going to come out to be manganese. Because remember, the 3D strontium is out of the options because strontium is group 2. Group 2 is only S2. Phosphorus is out of the contention because phosphorus is group 5, that's S2P3. The only ones left is
magnesium.
Huh? Manganese Mn has it's a transition metal. It's got 25 electrons. So the reason you're going to go for transition metals is for transition metals, the 3D is being filled up. So you should immediately be able to identify that this is a transition metal. Actually, this one, the last one, what are the two shapes? Non-linear and trigonal planar, right? Okay, so BF3 has no lone pairs, it just has 3 bonds, so it's going to be fan shaped, and We did draw water over here. Water has two lone pairs. The lone pairs are not counted in shape. So the water
Bent
molecule
shape.
has a bent shape or known as a non-linear shape. Chala, theek hai, let's continue tomorrow then. Theek hai, I'll share the video lecture as well.
Okay, sir.
Okay,
Thank you.
Take care, love.